Hi, this is Homework Helpers studying for the third quarter final. This review sheet is gas laws. Okay, gas laws are mostly calculations. I'll go over a couple of the diagrams and other information that you need to know. The calculations for gas laws is located on Table T. We're going to use the combined gas law. The combined gas law is pressure 1, volume 1, temperature 1 is equal to pressure 2, volume 2, temperature 2. The key thing that you need to remember here is the temperature must be in Kelvin. So you may have to use this formula. Kelvin is equal to degrees Celsius plus 273. If you're given a temperature in Celsius, you have to convert it to Kelvin in order to put it into the formula. Now, if we're doing this, these types of problems, and let's say the temperature is constant, I simply remove it from the combined gas law, and you're left with P1V1 is equal to P2V2, which is Boyle's law. Let's say the pressure is constant, I just remove it. And then I have volume 1 over temperature 1 is equal to volume 2 over temperature 2. And that would be Charles's law. If the volume is constant, I just remove it, and I've got P1 over T1 is equal to P2 over V2, T2. And that would be John's law. All right, so let's take a look at a problem. What is the new volume of 5 liters of a gas at 3 atmospheres and 546 Kelvin if the conditions are changed to STP? So to set this up, I'm going to be very careful. I'm going to set up my variables so I don't make any mistakes. There's a lot of stuff to look for here. Okay. So we're looking for a new volume, so that's going to be my V2, of 5 liters, so that's my T1, if it's at 3 atmospheres and 546 Kelvin. So it's already in Kelvin, I don't need to change the units. Now here, I'm told we're at STP. STP is in the front, okay, standard temperature and pressure. Since I have my first pressure in atmospheres, I'm going to use atmospheres for my standard pressure, and that would be 1 atmosphere. If my original number was in kilopascals, then I would have used the standard 101.3 kilopascals. Now for standard temperature, I'm going to use my Kelvin temperature, 273 Kelvin. So now I've got 5 of the 6 variables. Let's use this formula to plug them in. I've got 3 atmospheres times 5 liters over 546 Kelvin is equal to 1 atmosphere. I'm looking for my volume over 273 Kelvin. Now the way I'm going to solve this is I'm going to cross multiply. It's helpful if you write out the in-between numbers so you don't make mistakes. So that's what I'm going to do. I've got 3 times 5 times 273. Expect a big number. I've got 4,095. And I've got 546 times 1, 546x. Now I'm going to divide by 546. That cancels. So x is going to be my 4,095 divided by 546. And that gives me 7.5. Now that's a volume. My volume, first of all, was in liters, so this is going to be in liters for my second volume. So that's 7.5 liters. Okay, that's a basic combined gas law problem. Expect to see at least one of those in the multiple choice on the exam. All right, so let's look at some of the graphs. You have to know these relationships. Remember, you can take a PTV card. Okay, you can design this or write it in the corner of your paper. This is in alphabetical order: pressure, temperature, and volume. So if pressure increases, what happens to volume? I hold my finger on temperature and I increase pressure by turning the P above my finger. The volume will go down, so that decreases. All right, this is an inverse relationship, and the graph of an inverse relationship, pressure volume, is going to look like that. Now, if I look and hold my temperature's constant, and, my volume constant, and I increase my temperature, that's going to move both letters above my finger, So that is also going to increase the volume. So basically anything that temperature does, pressure and volume do the same thing. So this is a direct relationship. If I put temperature on the bottom and volume on the side here, a direct relationship graph looks like that. The next one, as I hold volume constant. As temperature increases, pressure also increases. Again, my graph is going to be a direct relationship. So the graph's going to look like that. Okay, put temperature on the bottom, pressure on the side. So let's do this last concept. A real gas as most like an ideal gas. So we learned about kinetic theory, kinetic molecular theory. And that tells us about the behavior of gases. Most important thing, gases move in straight lines and they diffuse from high concentration to low concentration. Okay? And remember that these are ideal gases. So real gases will behave most like ideal gases if the pressure is very low. So that means the molecules are far apart. And the temperature is high. And that means that the molecules would be moving very fast, so they'd be zipping past one another. And if gases have low masses, like hydrogen or helium, those are our two least massive gases on the periodic table, then that will also allow a real gas to act most like an ideal gas. So it would be high temperature and low pressure. And my analogy was, how do I like my boyfriends? I like them hot, no pressure, low body weight. Okay, so this is just an example of gas laws for the third quarter final. Please make sure you do the CASEL learning assignments, and good luck studying for the third quarter final, which will be on Friday.